Welcome to the next lecture of non-destructive testing. This is Salman, Assistant Professor of Mechanical Department, ISR College of Engineering. In today's lecture, we will discuss about our third unit of non-destructive testing, which we have stopped till here in previous lecture. So let us discuss the further topics. That is nothing but attenuation of sound waves. So this is nothing but it is a combined effect of sounds getting scattering and getting absorbed. You might have heard that in most of the theaters there will be a soundproofing system which tries to avoid the sounds to go out and it tries to reflect the sound within the theater. So that is nothing but called as attenuation of the sound waves. So it is a combined effect of scattering and absorption which states that when a sound beam travels through any medium, its intensity actually gets reduces because when it enters from one medium to other medium, its velocity obviously decreases. So the attenuation is generally defined as is given by a mathematical equation A is equal to A naught e power alpha z. So where A naught is nothing but an initial or unattended amplitude because if the natural frequency of the sound wave which you are taking, and alpha is nothing but the attenuation factor, which medium you are going to consider, and the traveled distance, to what distance it is being traveled. Okay. So the ultrasonic tests are generally carried out by using various test techniques. Generally, we will follow. We will try to see what are the techniques we generally use in ultrasonic inspection technique. So the very first technique is nothing but pulse echo transmission, and next is normal beam and angle beam, and the final one is contact and immersion. So pulse echo and through transmission is nothing but in pulse echo we will see that the sound waves is passed through a material. When the sound waves are getting reflected back, and the echo, the what is that is nothing but echo. For example, if you are going to some hilltop and you are loud, you are making some noise, you will be hearing back that sound after a few seconds. That is nothing but echo. So the same phenomenon we generally do in materials. We will try to send sound signals to the through the material. When the sound passes through the surface, after it touches the other end of the surface, it gets reflected back. So what time it has taken, because basing on that we can able to identify is there any delay. If the delay is there will be a proper timing. So for example, you are sending a 50 hertz frequency sound wave. If it that will be fixed that if it is 50 hertz, it is passing through a thickness of 10 mm. When returning back, its frequency should be 40 hertz because it is going to one surface and coming back. So during this travel, it will obviously lose its frequency and wavelength. So we'll be know that it will get that 40, 50 something, not more than 50, but not even equal to 50. It will be less than 50 itself. So during this, what is the delay happening? If there is some flaw present inside the material, that is nothing but if some hole is present inside the material, because of that hole, what happens to the sound waves? It will get reflected back before the original time, before the echo time. So basing on that, we are able to identify the position of flaw and position of and the time taken to the flaw. Okay. So next is through transmission. And through transmission, what we do is we will send the we will send the signal from one surface and we will receive the signal on the other surface. We will not get back the signal to the same origin point. We will be getting the transmission and we will be observing the what we say the complete transmission, and after that we will be going to receive the signal. We need not have a receiver on the same end as the original end. That we will see in the further classes, further slides. Now, next is normal beam and angle beam. Normal beam is nothing but we already know what is normal. If you are sending a signal perpendicular to the surface which you are going to test, and angle beam is nothing but we will try to send the beam in such a way it makes some angle with the surface which you are going to test. What is the importance of normal beam and the angle beam? Nothing but, for example, all the flaws which are present in the surface need not to be vertical or horizontal. So there may be some flaws which are made in some angular. So basing on that, we can able to identify by using angular beam. Next is contact and immersion. Contact is nothing but is the two surfaces. This is nothing but the testing surface and the what we say the material which is to be tested, the source of the ultrasonic testing, both are in contact with one another. That is called as contact type of testing. Another one is immersion. Immersion is nothing but both will be kept in one certain medium. That is nothing but generally we use water. So in that water we will send some signals basing on the reflections. We will be going to test the material. Okay. So the pulse echo, this is the method most commonly utilized in ultrasonic testing. So the transmitter and the receiver probe are on the same side. This is the very most important things in the pulse echo method, and the presence of defect is indicated by the reception of echo is nothing but the reflection light when it is coming back, that is we call it as back wall echo. So when it finally touches the end surface and comes back to the original surface, then to this we will be connected to a CRT scan, that is nothing but you might have seen in a hospital there will be a reading which will be used to study the heartbeat. Similar thing will be used in a this technique which will be showing this. So this is the generally pulse echo technique. So you can see here. So if you are sending a signal, so initially it will have the transmission pulse like this. When it is getting reflected back from the outer surface, I already told that if it is 50 hertz, that 50 hertz will not be able to obtain. Obviously there will be some decrease, but the decrease will be based upon the thickness of the material. So we are going to get like 40. If there is some defect existing, because of the defect, the material, the sound wave will be getting reflected back to the receiver. So because of that, we will be receiving an extra scan, extra line, okay, extra peak. So because basing on this peak, we can able to identify the distance. Also, we can able to basing upon that what we say the length of the what we say length of the hole, we can the peak will be existing. Okay. Next is if there is a large echo, we are going to obtain like this. And because of this large echo, when the sound wave is completely withheld by this, which is completely restricted by this hole or the large defect, because of that we cannot the sound waves cannot go back to the last surface and cannot get back the echo. So because of that, there will be no wall back wall effect, but whereas we will be getting a huge defect echo. Okay. Next is pulse echo technique. It generally uses a single props, sends and receives both the signals. The device which you are generally using for sending the signal itself will be have a receiver which receives the signal. Okay, gives an indication of defect and depth in the and dimensions, not fail safe. Okay, so through transmission, this is the method we have two ultrasonic probes where one is transmitter probe, another is a receiver probe. Okay, so in this way we will send the signal from one side, another side we will try to receive the signal. So when you send the signal from one side and you receive the signal, you will be getting these two type of waves. If you are having an what we say echo, if you are having a defect, we will be observing or receiving only one signal. Because of that, because of the presence of the flaw, what happens? Some sound waves will be getting reflected back because of the flaw, and some signals will be reaching to the back surface. That is nothing but they will be reaching to the receiver. They will be receiving a small signal. But whereas if it is present a complete large hole, then we cannot able to receive the signal at the end. Then we will be having only initial deformation in the CRT screen. Okay. So these are the few through transmission images. Okay. Next, what are the advantages or disadvantages of that through transmission technique? Is nothing but less adhesion. That is, even absorption and diffraction will be less in this. No probe ranging will be there. That we should use a probe only of this range. If the thickness of the material is too large, we cannot every time we cannot use the same probe. Basing on the receiver signal, the sensor should be changed. So, but whereas if it is the receiver used in the transmission technique, you can use any kind of sensor that will be ready to accept your signals. Okay, so no dead zones will be there. Orientation does not matter in any type of orientation. If you are ready, if you are able to receive the signal, means there is no hole. If you are not able to receive the signal, means there is some flaw present inside the material. The main disadvantages is that the location of the defect cannot be identified. Either it is present next immediately to the surface or in the center of the surface or away from the surface, that we cannot able to identify in this. Okay. This can be used when we have this cannot be easily automated. Okay, need access to the both the surface. We should be access. For example, we cannot there is some underground pipeline. So for the underground pipeline, we cannot go to the bottom surface. So in that type of techniques, this is not useful because both the sides we should have a sensor. So if you want to go under the pipe, it is a complicated thing for you. So the true transmission cannot be used in such type of things. So at that time, you can able to go for pulse echo technique. So basing upon the advantage, basing upon the type of application, you have to use what technique you can able to use. Next is transmission with reflection, also known as tandem technique and pitch and catch technique. So resonance, what is resonance is nothing but we already know what is resonance. If same frequency waves matches with one another, the range of the frequency will be obviously increasing. The best example from the childhood we are keep on studying is the military people when they are walking on a bridge, they will not march on that, because if the frequency of your marching and the frequency of the surface if matches, the frequency will be go out of control and it will lead to fail. Okay, so for that is the reason the resonance method is used. In this method, a condition of resonance should come into existence. So that what is the condition for that? That the condition for that is nothing but the thickness of the material should be exactly half of that of the sound wave, or multiples of the material. Okay, multiple of the thickness of the material. Okay. Next, the control of the wavelength in ultrasonic is achieved by control of frequency. Obviously, how we are going to control the wavelength of the ultrasonic wave is nothing but by just controlling the frequency. You can able to control the frequency, you cannot able to control the wavelength. Resonance method, knowing the resonance are the fundamental frequency, that is nothing but the velocity of the ultrasonic in a specimen. The thickness T can be substituted. The thickness can be calculated for a material. For example, we know the frequency of a material, we know the velocity of sound, then obviously we can able to calculate the thickness of the material. That is T is equal to V by 2L. That is velocity by frequency. Since it is difficult to recognize the fundamental mode of vibration of the fundamental frequency is calculated from the difference of two adjoint harmonies. That is nothing but if in cases if there is we are using some kind of frequency whose natural frequency or whose fundamental frequency is not known, then what we can do is we can send two frequencies. One is first frequency, other is second frequency. What is the difference between these two frequencies that we are going to calculate? Basing on that, we can able to calculate the thickness of the material. So this method is used for the inspection of large ignots, nothing but big things. Okay, like you might be using clamps. Ignots generally use clamps, and casting particularly when the authentication is highly and gross defects are present. Gross defects means huge defects are present. Casting, you can see that if you are not properly casting the material, there will be a large amount of holes will be present. Okay, the method does not give a size and location of the defect. In addition, good mechanical coupling and alignment of the two props is essential. So in this technique, we have to use a coupling and alignment of the props should be done properly, because the resonance has to be done. Okay. The technique of ultrasonic testings are either of contact or by immersion. The next method is nothing but in contact or immersion. In contact, the probe is placed in direct contact with the test specimen. The thin liquid fluid which is used as a couplant for the better transmission. This couplant is used to improve the what we say the frequency of the wave. We will see about couplants. The next is the immersion type. Waterproofing proof. A waterproof probe is used in at some distance from the test specimen, and ultrasonic beam is transmitted into the material through water or water column. Okay. So in the contact type. In this contact type also we have two types, that is normal beam technique and angle beam technique. In normal beam technique, the ultrasonic beam is projected perpendicular into the specimen. This technique may be used either single, double or normal beam probes. So with the single probe, the transducer of the probe acts as both transmitter and receiver. In double probe, we will be having two through transmission can be done. Okay. So the same techniques can be used again and again in one another. First, we have seen that pulse deco. The pulse deco can be used in contact and non-contact. So basing upon the type of application, we are going to change it. Next, angle beam technique. The angle beam technique is used to transmit the ultrasonic waves in the test specimen at predetermined angle to the test surface. So the transfer waves at various angles of refraction about 35 to 80 degrees are used to locate the defects whose orientation is not suitable for detection by normal beam. If there is some what we say, there are some kind of flaws which we cannot be generally used, cannot be identified by using a normal beam, then we can able to see that there is any flaw which is present at some angularity till 80 degrees, you can able to identify by using this angle beam technique. Next is surface wave technique. This is nothing but in this what we do is we will try to align the sound waves along with the surface. That's it. So the surface wave techniques has used very successfully for a great number of applications, particularly aircraft, because aircraft surface is not an even surface. It is like if you see that the nose is having a curvature, the body is having some curvature, so we cannot use we cannot use some normal beam of angular beams. So along the surface we have to send some signals. So the main advantage of the surface wave is that they follow the gentle counters. Counters is nothing but if this is if we draw some line like this. So this is called as contour. So contour plots generally the path, okay, spline path. So the spline path you have to follow the it should follow that spline path and get reflected back only by sudden change in contour. If there is some sudden changes that is happening in the contour or sudden changes happening in the shape of the material, then it has to be studied, thus making it very useful tool for the examination of complex surfaces. The main limitations of this surface is nothing but it is immediately authenticated if the surface is rough. Obviously, if the surfaces are rough, the whole rough surface will be able to absorb the whole sound waves. Okay, if it is having if it is so it is covered in scale or liquid such as couplant, or if the pressure is applied by the other object such as hand or operator. If you are having this, immediately these are the main limitations of surfaces. Immersion type technique, immersion testing technique. So immersion testing techniques are mainly used in laboratories for large equipments, because the sound wave should not be exposed those frequencies. If get exposed to ears, you may lose your ears. So because of that, what we do is we try to send them underwater. Okay, like submarines during automation ultrasonic testing, it has the advantage that uniform couplant conditions are obtained and longitudinal and transfer waves can be generated with the same prop. Okay, simply by changing the angle. So the immersion technique, both the prop and the test specimen are immersed in water. The ultrasonic beam is being directed through into the water into the test specimen using the normal beam technique or angle beam technique, through which we can able to generate longitudinal waves or either transfer waves. So how the what is the speed or what is the generally we use the speed technique is nothing but the thickness of the specimen into sound velocity in water divided by sound velocity in the specimen. Okay, the distance can be calculated like this. So these are the first specimen. If you are having a first surface, so this is the result of the first surface. Same. So most of the time we use a CRT screen where we can able to study the this thing. Again, this is initial. So this is because of this transmission and initial echo. Next is back wall echo. So this IB is nothing but when it touches this surface, first surface, because of the change of the medium, we will be having an echo. So that echo is this one. This is the second echo. Whereas in this, if you see, this is the first echo. This is this last echo. In between this, because of the presence of law, you can be able to see this. Okay, in that way you can able to identify. This is a normal one, this is a angle beam. So this probe is kept at some angle through which we are going to make it a transfer. Okay, so immersion technique, in this bubbler or squirting technique is the ultrasonic beam is directed through a water column into the test specimen. This technique is usually used with the automated system for high speed scanning of the plate, sheets, strips, cylinder form and other regular shaped forms. So this is the bubbler technique, where this is the wheel transducer technique. Bubbler technique is nothing but we will be having a ram type structure which is present inside the water. This is a transducer which generally sends the signals. So this is a test specimen which is kept on the water. Because of the frequency, as the frequency increases, the water will flow out from the surface. So overflow will happen if this is having if this is sending large amount of signals. So that is nothing but called as bubbler technique. Whereas in this is a transducer which is in place. So this transducer is filled within the water and it can be able to rotate along the surface. So it will be moving on the surface. That is what rotation can be done. So wherever the presence of surface, where presence of loss is there, that can be studied by using a transducer. In immersion wheel transducer, that is nothing but the wheel transducer. The ultrasonic beam is projected through the water-filled tire in the test specimen. The probe mounted on the wheel axial. So this is the probe where it is held in the fixed position while the wheel and the tire rotates. Okay. So equipments. What are the various types of equipments which are generally used for ultrasonic testing is nothing but instrumentations. What are the various types of instrumentations, transducers and calibration standards. So transducers are nothing but it's our variety types of transducers are there basing upon the shape, basing upon the type of application. So we are having different type of transducers. For contact type we have different, we have for immersion type we have different, for single sided we have different, for double sided the single sided is nothing but we are having in that we will have both receiver and a sending signal, whereas in dual one side it will be a sending probe, another side it will be a receiver probe. Okay, similarly for normal and angle also different type of transducer are there. In selecting a transducer for given application, it is important to choose the desired frequency. So because the transducer will send the frequencies, we have to be very careful before we select the transducer. Okay, bandwidth, size, and some focusing will which optimize the inspection capabilities. Contact transducers. In the contact transducer are designed to withstand the rigorous use. Means because it is obviously used always in the surfaces, it should be used in such a way so that it can withstand a large amount of pressure. And usually have to wear plate on it on the bottom because it should not get weared out of the surface to protect the piezoelectric element from the contact on the surface to test article. Many incorporate ergonomic designs for the ease of grip while scanning along the surface. Means when you are trying to move the contact type of transducers along the surface, it should have the ergonomic. Ergonomic means it should be much helpful for the human so that they can easily hold. They can easily try to travel along the surface. For example, if you see this, so it is having a curvature on this. Because of this, what happens when you can easily hold by using a thumb and a pointing finger. You can easily hold. You can directly transport. For example, you see the stethoscope of a doctor. It will be having a provision so that he can able to hold the reading device easily. So in that way, the ergonomics should be done properly for this. In contact transducers, the transducers are available with the two piezoelectric crystals in it. So these are the piezoelectric crystals. So one is for the sending signal, another is for receiving. Okay. So this arrangement improves the near surface resolution because the second transducer does not need to complete a transmit function before listening for echo. So the dual elements are commonly employed in the thickness gauging of thin materials. So, so with this we will try to stop this and we will try to continue the further topics in our next lecture and we will try to end this ultrasonic testing in next class. Thank you.